All right, this is your test one review for Mac 1105. Question number one, the volume of a gas V is held at constant temperature in a closed container and it varies inversely with its pressure P. If the volume of the gas is 450 cubic centimeters, when pressure is 400 millimeters of mercury, find the volume when the pressure is 600 millimeters. All right, so since that volume we're told in the question varies inversely, we will write our inverse equation as it relates to pressure being V equals K over P. Remember, the letter K stands for the constant of proportionality. Now we're going to use this equation V over K divided by P in order to actually find the value of that constant. We need to find K, and we would substitute what's given to us in the equation. We're told that the volume is 450 cubic centimeters, so we'll substitute 450 into our equation for V, for the volume. So instead of V equals, we write it as 450 equals. We're also told that the pressure is 400 millimeters. That's given to us in the problem. We're going to substitute 400 for P in our formula. So we're left with 450 equals K over 400. And to solve this equation, we will do the opposite. The inverse of dividing by 400 is to multiply both sides of this equation by 400. And when we multiply both sides of the equation by 400, see the 400s cancel on the right side, leaving K. On the left side, 400 times 450 gives us 180,000, and this is our constant of proportionality. So K equals 180,000, and from here on out, we will substitute this value for K. Next, we want to find the volume. This is given to us. We want to find the volume when the pressure is 600. So we'll substitute 600 for the pressure and also use the K that we found earlier to help us find that total inverse. Remember, volume is equal to the constant of proportionality, K, divided by pressure. The constant of proportionality we just found in part one is 180,000, so we'll substitute 180,000 for K. The pressure is 600. We're substituting 600 for P. When we divide 180,000 by 600, we'll get the answer to our question, and that is that the volume is 300 centimeters, cubic centimeters. And that's our answer. For number two, the distance S. So we're using S to represent distance. That an object falls is directly proportional. So this time it says direct proportionality to the square of time t. If an object falls 16 feet in 1 second, how far will it fall in 6 seconds? Then how long will it take for that object to fall 144 feet? So what we want to do first is set up our direct proportionality equation. And that equation will be related directly to the statement, which it states that the distance is directly proportional to the square. Now, direct proportionality equation, if we were to use x and y, would be y equals k times x. Always using k to represent that constant of proportionality. But since our distance is directly proportional to the square of t, we're going to be using s and t. Our distance s is directly proportional to the square of t. Squaring t means to raise t to the second power. So that direct proportionality equation would be s equals k times t squared. And remember, k is our constant of proportionality. And we want to find the value of k first. So we'll use this s equals k times t squared. Substitute the first two pieces of information that are given to us, and that is that our distance, we said that the object falls 16 feet. For s, we would substitute 16 in 1 second. So for t, we substitute 1. So in our equation, we have 16 equals k times 1 squared. 1 squared is just 1, so we're left with k equals 16. This is our constant of proportionality. And we're going to use k to help us answer these two parts of the question. How far will the object fall in 6 seconds? This time is 6 seconds, so we'll substitute 6 for t. So right here in our equation, we're substituting the number 6 where t is, and we already determined that our constant of proportionality is 16. So remember that original equation was S equals K times the square of T, so T squared. And we determined that our constant of proportionality is 16. So that's why we write it as 16 T squared. And then we substitute 6 for T. 6 squared gives us 36 times 16. We'll get that distance, and the answer to our question is 576 feet. Now we're also going to use that same equation using 16 as our constant of proportionality, S equals 16 T squared, to find the time. This time we want to know what T is when the object falls a distance of 144. And S represents our distance. So for S, we substitute 144, carry that down. We'll get 144 equals 16 T squared. And to solve, we would just divide both sides of this equation by 16, right? And when we divide both sides by 16, the 16s will cancel on the right side, leaving T squared. 144 divided by 16 gives us 9. And to solve this, we would take the square root of both sides, and we get T equals plus or minus square root 9. The plus or minus square root 9 actually gives us 3, or positive 3 or negative 3, right? And since we're talking about time, guys, time can only be positive, right? So we're going to disregard that minus 3. And the answer to our question would be positive 3 seconds. For number 3, we want to find the center and the radius of this given circle, and then we're going to write the equation in standard form. So remember the standard form of an equation, x minus h squared plus y minus k squared equals r squared. What we want to do first is find that center and the radius. Remember, the ordered pair format for our center is hk. Now look at our given circle. We see our center is here at -4, 2. So here's our center. And then the radius, that distance from the center of the circle to the end point, is 1, 2 units. So our radius is equal to 2. Our center is -4, 2. And we're going to use this information. Our radius, remember, is hk. So everywhere h is, we'll substitute -4 into our formula. Everywhere k is, we're going to substitute the number 2. And our radius is also 2. So we'll substitute the number 2 for r into our equation. So here we substitute -4 for h. Remember, a negative times negative will make this positive. And then for k, we substitute 2. For the radius, we substitute 2. So we have y minus 2 squared, and then 2 squared, 2 times 2, that gives us 4. This would be our equation simplified. X plus 4 squared plus y minus 2 squared equals 4. Next, we want to find intercepts and test for symmetry using this equation, 25x squared plus 4y squared equals 100. To find the x and y intercepts, remember every x intercept, y equals 0. So we will take that original equation and we're substituting 0 for y. We have 4 times 0, that's just 0. Carry down 25x squared equals 100. Divide both sides of this equation by 25. And see the 25s will cancel on the right side, or leaving on the left side, leaving us with x squared. On the right side, 100 divided by 25, we get 4. And again, we're going to take the square root of both sides. So x equals plus or minus the square root of 4, or plus or minus 2. Square root of 4 gives us 2. But we do want to write those solutions in the form of ordered pairs, right? So we write those ordered pairs as 2, 0, or -2, 0. For the y-intercepts, we substitute 0 for x. We're substituting 0 for x. When we substitute 0 for x, see this 25 times 0, that cancels out, leaving us with 4y squared on the left equals 100. Divide both sides by 4. The 4's will cancel on the left, leaving y squared equals 100 divided by 4, which is 25. Take the square root of both sides. We'll get y equals plus or minus square root 25. That square root 25 gives us 5. But we want to write those two values as ordered pairs. So we should write our ordered pairs as 0, positive 5 or 0, negative 5, right? The two ordered pairs. So there we have our intercepts. Next, we need to test for symmetry. So testing for symmetry involves substitution. To test for x-axis symmetry, we're going to substitute negative y for y into the original equation. So here's our original equation, 25x squared plus 4y squared, but we're substituting negative y where the letter y was. But remember, negative y squared, negative times negative is going to be positive y. So we wind up with the equivalent to the original equation, that 25x squared plus 4y squared equals 100. Therefore, there is symmetry about the x-axis. To test for symmetry along the y-axis, we're going to substitute negative x for x into the original equation. And again, negative x squared, that becomes positive x squared, which is equivalent to the original equation. Therefore, we have symmetry about the y-axis. To test for symmetry about the origin, we're going to substitute both x and y. Negative y for y, negative x for x, and then we want to simplify. And when we do that, we'll wind up with the original equation simplified as 25x squared plus 4y squared. And therefore, there is symmetry about the origin. And then you're done. Next, we want to find the midpoint of the line segment that has endpoints negative 110 and 10, 0. So we want to first label our points. That first point I'm going to label as x sub 1, y sub 1. The second point we're going to label as x sub 2, y sub 2. And then here's our formula to find the midpoint. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. We'll substitute these values. So our x1 plus x2, negative 1 plus 0, that gives us 9 over 2. Our y1 plus y2 gives us 10 plus 0 over 2. 10 divided by 2, that gives us 5. So this is our midpoint. Next, we want to find the distance between 4, negative 3, and 2, 5. Using our distance formula, the square root of the difference in the x coordinates, so x sub 2 minus x sub 1, and y sub 2 minus y sub 1 squared. So x sub 2 minus x sub 1 will get, after we label these points, if we label them as x sub 1, y sub 1, and x sub 2, y sub 2 will get 2 minus 4, the difference in our x coordinates. 2 minus 4 gives us negative 2, and negative 2 squared is positive 4. The difference in our y coordinates will get 5 minus negative 3. Remember, minus minus, this will become addition. 5 plus 3, which is 8 squared. 8 squared gives us 64. We add those together, we'll get our distance is square root 68. Next, we want to solve this inequality. We have absolute value of 4x minus 9 greater than or equal to 8. We want to rewrite this as an or statement. So using the word or, we'll take the terms that are underneath the 4x minus 9, make it greater than or equal to the positive or less than or equal to the negative. So 4x minus 9 greater than or equal to 8 would solve this inequality. To solve that inequality, we're going to first add 9 to both sides of the inequality. 8 plus 9 gives us 17 on the right side. Carry down 4x, and then we want to divide both sides by 4. So we'll get x greater than or equal to 17/4. For the second inequality, we'll want to add 9 to both sides. Negative 8 plus 9 on the right gives us 1. Divide that by 4, and we'll get x less than or equal to 1/4. Next, we want to graph on a number line and then write that solution using integral notation. So x is less than or equal to 1/4. So right here, 1/4, we will use our brackets. Remember, you either use a bracket or parentheses. If our inequality symbol is less than or equal to, or if it's greater than or equal to, you want to use brackets when you're representing using integral notation, okay? Use brackets if the inequality symbol is less than or equal to or greater than or equal to. If the inequality is less than by itself or greater than by itself, you're going to use parentheses, okay? And since we have less than or equal to and greater than or equal to, we used brackets for this question. So looking at our number line, we drew those brackets right there in both positions. Right here at the 1/4 and again at the 17/4. Brackets. And x is less than or equal to 1/4. So we have bracket at 1/4 and it runs to the left. That's in the direction of negative infinity. So we write our interval notation by closing in negative infinity with parentheses. You always use parentheses to enclose infinity. Or this U in between these two statements represents the word or. We put a bracket again at 17/4. Why? Because our inequality symbol is greater than or equal to. And we're shading to the right side. That's the direction of positive infinity. So we enclose infinity right here with parentheses. But this would be our interval notation. Next, we want to find the real solution. So we want the real number solutions. We have absolute value of x squared minus 6x equals 16. So again, we want to set up two inequalities, but this time they're going to be equations. The first one, x squared minus 6x equals 16, or the second one is x squared minus 6x equals negative 16. We'll solve here first by creating our quadratic equation. We subtract 16 from both sides. We get x squared minus 6x minus 16 equals 0, which we then factor. Find two numbers where when we multiply them, we get negative 16, but when we add them, we get negative 6. And that's x minus 8 or x plus 2. We use our two factors to create two equations. So we have x minus 8 equals 0 or x plus 2 equals 0, and then we solve both those equations. Solve those equations, we subtract 2 from both sides, so we get x equals negative 2, or for the first equation, we would add 8 to both sides, and we get x equals 8. So our two solutions, x equals 8 or negative 2. These are real number solutions. Now for the second equation, we would add the 16 to both sides first, and that would give us x squared minus 6x plus 16, which we can't factor. So we apply quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. And when we substitute for b, we substitute negative 6. Negative 6 gives us positive 6. And then b squared, that's negative 6 squared is 36, minus 4 times 1 times 16, minus 64. This gives us a negative number under the square root, which we know will not be a real number, okay? And we were looking for real number solutions, so we don't have to continue there. Next, we want to find the real number solutions for square root 6x plus 1 minus square root x minus 4 equals 5. The first thing we want to do is isolate these two radicals. So we add that square root x minus 4 to both sides of the equation. When we do that, we get square root x minus 4 plus 5 on the right side. On the left side, we have our square root 6x plus 1. Then we want to remove the radicals. So we raise each side, the left and the right, we put them both in parentheses, raise them to the second power. Over here, we're going to have to distribute. You have to distribute that square root x minus 4 plus 5 times itself. And when we multiply square root x minus 4 times itself, we get square root x minus 4 squared. Square root x minus 4 times 5, we get 5 square root x minus 4. 5 times square root x minus 4, we get another 5 times square root x minus 4. And then 5 times 5, we get 25. Combining like terms, 5 square root x minus 4 plus another 5 square root x minus 4 gives us 10 square root x minus 4. Carry down the 25, carry down here, square root x minus 4 squared, that just gives us x minus 4 without the radical. We combine like terms, okay? So that minus 4 and the plus 25, those two can be combined to get 21. Carry down the x and carry down the 10 square root x minus 4. On the left side, carry down 6x plus 1. We want to continue to solve here. To do that, we're going to carry over the x and the 21. So we subtract x from both sides. 6x minus x gives us 5x. We also subtract 21 from both sides. And 1 minus 21 gives us minus 20. From there, we want to divide each side, everything on the left and everything on the right, by 10. So the 10s cancel on the right side, leaving square root x minus 4. Negative 20 divided by 10, that gives us negative 2. And then 5 over 10, that can be reduced to 1/2. So we write it in its simplified form as 1/2 x. From there, we're trying to get rid of that radical again. So we put parentheses around both the left and the right side. We want to raise them both to the second power. The square root x minus 4 squared is just going to be square root x minus 4 without the radical on the right side. On the left side, we have to expand this and multiply that binomial, that 1/2 x minus 2 times itself. So we distribute 1/2 x times 1/2 x, that gives us 1/4 x squared. The minus 2 times 1/2 x, that's minus 1. And then another minus 2 1/2 x, that's together would be a minus 2. The 2 times the 2 will give us positive 4. Negative times negative will make that positive 4. And then from there, we want to combine those like terms. So we add that 4 to both sides, and we subtract x to both sides. Subtracting that x, negative 2x minus x gives us negative 3x. And then 4 plus 4, that gives us 8. From there, we're going to apply our quadratic formula again. Negative b, we get minus 3. Our b term is negative 3. And b squared, that's negative 3 squared, which becomes 9. Minus 4 times a times c. So minus 4 times the 1/4. 4 times 1/4 is actually 1 times 8. That gives us 8. So 9 minus 8 gives us 1 underneath that radical. That's 3 plus or minus square root 1, all divided by 0.5. Remember that plus and minus gives us two potential solutions. 3 plus square root 1. Square root 1 is just 1 divided by 0.5, or 3 minus 1 divided by 0.5. But when you simplify, you should get x equals 8 or 4. And next, we want to solve the equation x squared minus 6, or x squared plus 6x equals 16. First, we want to rewrite this equation as a quadratic equation. We want to subtract 16 from both sides. 16s cancel on the right side, leaving 0. So we have x squared plus 6x minus 16 equals 0. Factoring here, find two numbers where when you multiply them, you get negative 16. But when you add them, you get positive 6. And that's x plus 8 and x minus 2. Remember, to solve, we would set both of those factors equal to 0. So x plus 8 equals 0, or x minus 2 equals 0. And we want to solve both those equations. So we'll get x equals 2, or x equals negative 8.